we have a formula of CrBr3, and the question is, what is the proper chemical name for this one? And if we check it out, this one here is chromium 3 bromide. Why is it not choice B? Why is it not simply chromium bromide? Go ahead.
Because it's a variable charge portion of the periodic table.
Exactly, it has a variable charge. So if we go back, let's see here. Here's our periodic table. Chromium's one of them here that is a transition element that has a variable charge. Whenever we have a variable charge, we must show the Roman numeral that indicates the charge on that ion. And yeah, I think the rest of you, hopefully, you can catch on if you're one of the other two people. Okay, any questions? All right, then if you've not yet memorized your list of polyatomic ions, let's pull your list of polyatomic ions out. You were to have had this done for today. And of course, if you miss class, you should know where to find this stuff. Where do you find this stuff if you miss class? On D2L, right. Remember D2L, I have the content section that lists and shows every day the stuff that we go through, including any handouts. And so I would hope, anticipate that you have caught yourself up with this. Now, as a quick reminder from last week, what is it that most of these that we have to memorize have in common with each other? Most of them end with ATE. And if they end with ATE, what does that mean about their composition? They're polyatomic, correct? But what else? They contain oxygen. So an ATE suffix always means that they contain oxygen. Now, in this list, we talked about the fact that this list does not show those that end with an ITE suffix. So in your text on page 143, we looked at some examples here, and we compared those that have an ATE suffix with those that have an ITE suffix. So let's go back and look at this list here. Here's nitrate. This is the one you're memorizing. Don't shut off your answer yet. This is nitrite. You are responsible for knowing nitrite even though you were not memorizing it. If we look at chlorate, chlorate is one that you're memorizing, but you must also know the formula for the chlorite ion. Sulfate, the one that's circled here, is one that you're memorizing, but you are also responsible for knowing the formula of the sulfite ion. So following those trends, what is the formula for the phosphite ion? Talk with a neighbor before you commit yourself. Look at your list of polyatomic ions in case you forgot. What would the formula be for the phosphite ion? Which you won't see on page 143, nor will you see it on here, but you should be able to figure it out. Give me about 15 seconds. Okay, 5 more. Count down. 5, 4, 3, 2, 1. Correct formula is choice A. It's PO3, the 3 negative charge. And we go back and review. If it ends with an ITE suffix, how does it compare to the one with an ATE suffix? One less oxygen, exactly. So if you knew that phosphate, going back to your list of ions that you are to memorize right here, if you know that phosphate is PO4 with a 3 negative charge, then the phosphite ion is going to have one less oxygen. It'll be PO3 with a 3 negative charge. Any questions on that one? All right, so this is kind of laying the groundwork here today. We are going to be flying through the rest of our nomenclature today, and then at the end of the hour we're going to have a chance to do some practicing here of all the different sets of rules that we've gone through. And of course, we begin today counting on the fact that you remember what we went through last class. So last class we were just introduced ionic compounds. This was category number 2, ionic compounds with polyatomic ions. So again, if you don't have these memorized, let's have your list out. And you should also have a copy of your periodic table out. I'm going to pop in a periodic table right here for us to refer to. Anybody need a copy of the periodic table here to get going today? Anybody need a new periodic table? All right. So let's go. First one we're going to do for today. Let's try this one. And I'm going to look at my periodic table here. Let's try something like lithium sulfate. Lithium sulfate. And we're going to write a chemical formula for lithium sulfate. So first thing we need for lithium is to know its charge. And what is the charge in the lithium ion?
1 plus.
1 plus. And how do we figure out that its charge is 1 plus?
Look in the row.
It's right here in group 1A. Everything in group 1A, recall, has a 1 plus charge. So we have lithium with a single positive charge. And the formula for the sulfate ion is SO. It's 2 negative. How many oxygens? 4. Remember, this comes from your list of ones to memorize. Sulfate is SO4 with a charge of 2 negative. So if we have Li single positive, SO4 2 negative, how many lithium ions do we need altogether?
2.
How many sulfate ions? 1. So our formula is going to be Li2 SO4. Okay. Next up. Yes?
When we're entering like sulfate in on our, for the homework quiz, do we have to put it in parentheses?
No, in fact, if you put it in parentheses, it's going to be wrong. It'll be wrong. And next one here, we're going to look at parentheses so we can decide whether or not we include parentheses. So let's do it on this one here, since you asked about the parentheses. Aluminum acetate. Aluminum acetate. Now aluminum has a formula of Al with a charge of how many? 3 plus. Okay, remember, based on its position in the periodic table, everything in this group here has a 3 plus charge. So aluminum 3 plus. Then acetate. Suffix is ATE. Suffix of ATE, we know that means it contains oxygen. So this is on our list to memorize. Formula is C2H3O2, the single negative charge. So now that we know its formula, I'm going to slide this over here. How many aluminum ions are we going to need? 1. How many acetate ions are we going to need? 3 of them, right? Because we're going to balance the charge. So now, because we have 3 acetate ions to balance the charge of the 1 aluminum, the formula is going to be Al. And then, since you asked, what do we need here? Parentheses. C2H3O2, and outside the parentheses, a 3. And so why does this one here need parentheses and the first one did not?
Because there's one in there.
Right, there's only one. So when we only have one of a polyatomic ion, we don't include parentheses. If we have more than one polyatomic ion, then parentheses are included. So again, parentheses are not included when we only have one of a polyatomic ion, and if you include them, it will not be marked correct. You may have had a generous high school teacher that allowed it, but your high school teacher should not have been generous because that's not the way we write them. Yes?
And then we need to do the subscript, right? Instead of just a normal number on the outside.
Yes, and that's a subscript, because remember, subscripts, these are counts. So this is a count that tells us that we have 3 of these polyatomic ions. Okay. Anybody else? Okay, let's do the next one here. Let's try magnesium hydroxide. Magnesium hydroxide. Charge in the magnesium ion is how much? 2 plus. And of course that's because everything in group 2A has a charge of 2 plus. Hydroxide. Formula is OH negative. Once again, this is one of your polyatomic ions that you are to have memorized right here. Now, this is the only polyatomic ion you're memorizing that has oxygen in it that doesn't end with ate. It's not hydroxate, it's hydroxide. And again, some of these have a historical context to them, and this is one of them. So now, we want to balance charges. How many magnesiums do we need?
1.
How many hydroxides?
2.
So now if we write the formula, it's going to be Mg, and then what? Parentheses. And then an OH and a 2. And so again, parentheses are included whenever we have more than one polyatomic ion. In this case, we have 2 hydroxide ions, we need to put it in. This is one that I most commonly would see a mistake of, and most commonly I see it written like this. This is not correct, because of course if we write it like this, how many oxygens are we showing?
1.
Just 1. And we want to show that there's 2 oxygens in the formula here. And that group, that hydroxide, is a polyatomic ion that sticks together. Okay. Let's try one more. Let's try this one. Calcium chlorite. Calcium chlorite. Calcium is going to have a formula of Ca with a charge of 2 plus. Again, that comes based on its position in the periodic table right here. Chlorite. What's the key thing we need to look at in this name?
ITE.
The ITE, and that's because?
It'll make it drop off.
Right, it's going to make us drop the number of oxygens. So you did not memorize chlorite, you memorized chlorate. Chlorate is ClO3 with a single negative charge. So if chlorate, and we'll go ahead and write this off in the margin here, chlorate is ClO3 with a single negative charge. If this is chlorate, then the chlorite ion is going to be ClO2 with a single negative charge. So now we have 1 calcium ion. How many chlorite ions are we going to need?
2.
Okay, and again we put that in so the charge is balanced. So the formula becomes Ca, and then we put ClO2 in parentheses and 2 outside of those parentheses. And this would be the formula for calcium chlorate. Now I do want to quickly caution you on something here, and that something is, we already looked at something like the phosphite ion, which is PO3, the 3 negative charge. And of course that's because we looked at phosphate, which is where? Right here, which is PO4 with a 3 negative charge. Now simply because we can change the suffix, for example, if we look at something like the carbonate ion, which is CO3 with a 2 negative, doesn't mean that there's such a thing as a carbonate ion. So even though we change the suffix, doesn't necessarily mean that that exists. So for the things that do exist, we can write them down. But again, just because we can write a name doesn't mean that it's actually possible. Now, today when I drove by here, I drove through the parking lot of Best Buy because, anybody else come down Round Lake Boulevard? Yeah. So they got all that construction there. So when I went through, I saw big Star Wars signs up there at Best Buy today. Is there some Star Wars thing coming out or today? I don't know why they have all that stuff there. But anybody remember anything about carbonate from Star Wars?
So is it,
This is what Han Solo. Han Solo was encased in carbonite. Okay, so it's possible in sci-fi. Okay, but just because it's possible in sci-fi does not mean that it's possible in real life. Okay, so you may have heard of carbonite before, but it doesn't exist. All right. Now, if we go the other direction, let's say that we have this type of formula, Na3PO4, and we'd like to write a name. Now we simply name the ions that are present. Na would be
Sodium.
sodium. PO4 is
phosphate?
phosphate. We'll simply call it sodium phosphate. And if we had something like this, FeSO4. FeSO4 would be called iron.
Sulfate.
Almost. What do we need to do with iron?
Roman.
We need to put in a Roman numeral. And why is it? Let's go back from last class. Why is it that a Roman numeral is required for iron? Transition element. It's one of those that has a variable charge. Whenever we have a variable charge, we must include that Roman numeral. So, we want to include the Roman numeral on this one. We kind of need to work backwards. In this one here, sulfate. You should have memorized is the formula of SO4 with the charge of 2 negative. So what must have the charge been on the iron in this formula? 2 positive. It must have been 2 positive because we see that there's one of each of these. So because this is a 2 positive, that means that the name of this is going to be iron 2 sulfate. Iron 2 sulfate. Which means if we had this one here, Fe2 SO4 parentheses 3, the name of this one here, take a minute or two, and I'm going to pass these out because it turns out that they are actually 2 different substances. One is FeSO4, the other is Fe2, parentheses, SO4, 3. So you can see why we do need to distinguish them in terms of name. Iron what? Sulfate. What is this Roman numeral going to be? 3. Exactly. It's going to be iron 3 sulfate. And of course we get this one by working backwards, remembering that sulfate is always SO4 with a charge of 2 minus. So if it's SO4 with a 2 minus, we notice then how many sulfates were in this formula? 3 of them. So we have the 3 sulfates. And we see how many irons in this formula? 2. So if we know that the charges are going to balance, that must mean that the charge on the iron in this case would have been 3 plus. And so this charge right here is what leads to the Roman numeral. And so we wind up with iron 3 sulfate for the last one. Any questions on either of these two? Any questions on these? All right, next up, we're going to go to our third category of compounds. Our third category of compounds was binary molecular compounds. And let's just review for a moment what binary molecular compounds are. First of all, if it's binary, that means that there's how many elements?
2.
And if it's molecular, that means
Metals.
nonmetals and nonmetals or metalloids. So it's only nonmetals and metalloids in the formulas, which is different than ionic. Ionic has metals bonded to nonmetals. So these should have only nonmetals present. So let's try these out. Let's try something like Cl. What is going on here? I must have bumped something. So we'll close this. I got a little pointy dude. I can't even close it. Let's try this. Alt control delete. There we go. Still not. What did I do? My pointer's not working right. Let's see if I got another pointer here. Okay, we'll use that one. All right, let's come back here on this one now. Binary molecular compounds. Let's try something like this one here. We'll go with ClF3. ClF3. And then we'll do P2F4. So I bumped something here that I don't know what's going on. All right, now to name these, this first one, we would name something like this. The rules say that the first element is going to retain its name. Then we say that the second element is going to retain its root name. Onto which we add a suffix of IDE. And at this point, the rule sounds identical to the binary ionic compounds. We add in one more step though, and the additional step that we add in, I'd like to know what I did to this thing. The additional step that we are going to add in is this. We say that Greek prefixes are added. To indicate the number of atoms of each element present in the formula. So now these Greek prefixes These are ones that you will need to memorize. I know it seems like we're asking you to memorize a lot, but these are ones that you should know most of these already. And these are on page 149 in your text. And they are the prefixes mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. And I would suspect that you've heard of pretty much all of these before, with the possible exception of tetra, unless of course you remember what you learned back in, probably in geography, not geography, geometry, there we go, geometry. Back in high school if you took the geography, maybe in trig. If you talk about a tetrahedron is an object that has how many sides? 4 sides. You may have heard of a pentagon, or if you've been out to Washington, D.C., the Pentagon is a building that has how many sides? 5 sides. Stop sign has... Ooh, not paying attention, huh? 8-sided, it's an octagon. And if you are attaching nuts to bolts, most nuts are called hex nuts. And that's because they have how many sides?
6.
Who said 5? They have 6 sides. It'd be kind of tough to attach a 5-sided nut. All right. So now, if we want to go back and, oh, and by the way, the prefix mono is usually left off. Prefix mono is usually left off. If it is included, it's usually included with the second element in the formula. So again, the prefix mono usually left off. If it is included, it's included with the second element. So that means if we were to name this one, help me out now, this one would be
Chloride.
Chlorine. Oh, but how many fluorines are there? It's going to be tri. Fluoride. So again, we include prefixes, the Greek prefixes that tells us how many atoms there are of each element. P2F4 would be di. What is P? Phosphorus. And then we'd have tetrafluoride. Tetrafluoride. How about this one? SF6. SF6 would be, well, let's see, I got my pocket typing and everything. I must have this field around me. This is going to be sulfur hexafluoride. Sulfur hexafluoride. Here's one that uses the prefix mono. This is going to be carbon monoxide. Which does bring up a good point about this one. Notice we didn't call it carbon monoxide, we called it carbon monoxide. And that's because, for whatever reason, whenever we use a prefix that is adjacent to oxygen, we'll leave off either the letter O or the letter A. So, in other words, if we had something like P2F5, this one here is going to be diphosphorus. And then it will be oh, I meant to put P2O5, sorry. Put in an O here. That's why I want to show this one. It would have been pentafluoride, but in the case of oxygen, we leave off the letter A, so we'd simply call it pentoxide. So again, whenever one of these three prefixes is used adjacent to oxygen, the letter A is left off, or in the case of mono, the letter O is left off. And it's only with oxygen, it's not if it's with iodine. which also starts with the vowel. It's only with oxygen. So with that in mind, let's say we had something like AlBr3, and we wanted to write the formula for Al, or write a name for AlBr3.
For oxygen, is it like that with di and tri?
It's not that way with di and tri. So it's not doxide, it's still dioxide, like carbon dioxide. So it's only when we have the letter A or O on those Greek prefixes. Okay, so AlBr3. This one here is going to be called aluminum. And be careful now. This is going to be simply called aluminum bromide. Not aluminum tribromide, but aluminum bromide. And the reason for that is because this now is not a binary molecular compound. This here is a binary ionic compound. And that's because we have a metal combined with a non-metal. And so we need to remember that we can't forget those rules that we looked at before. This is binary ionic, so the prefixes are not included. The reason why there was 3 oxygens in the case of this one is because the charge on aluminum was 3+. But when we're dealing with molecular compounds, we don't have ions that are present, so we don't worry about any charges that are present in the formulas. And I'm kind of fidgeting around up here because I lost the tip out of my other stylus and I don't want to lose it. Okay, let's go the other direction. Let's say that we have a name like diarsenic, diarsenic pentaiodide, diarsenic pentaiodide, or we have tetraphosphorus decoxide. And now we want to write formulas for these. Now these are the easiest formulas we're going to do all day. There's no need to look up any charges whatsoever. The prefix di tells us we have 2. The prefix penta tells us we have 5. So this formula is going to be AS2 I5. Okay, do the next one here, please. When we do this one here, formula winds up being P4 O10. P4 O10. Okay, any questions on these? Hey, my stylus works. There we go. P4 O10. Any questions? Yes?
How many instances we have to write mono? Like before?
Mono is used very rarely. Carbon monoxide is one case where it's used, but usually the prefix mono is left off. If it is included, it's included with a second element.
I was reading ingredients on the Cheez-Its the other day, and one of them was monosodium glutamate.
Well, see, that's for the common person. That's not for the way we're learning rules for chemists type of thing, and we can't go through all of the possible combinations, but part of that is because monosodium glutamate, which is also called MSG, if you've heard of that before, I mean, that's not like a recent thing. That's more like about 20 years ago. There was a huge thing about MSG, and you go to a like an Asian restaurant, they'll say, our food has no MSG in it or whatever as kind of a selling point. And I think it's kind of all bogus anyhow. But and that's bogus. That's an old word too. I know. Okay, but it's because it's part of it's a way that you can name a compound where it's possible to attach more than one sodium to it. So glutamate comes from glutamic acid and has the possibility of actually attaching two sodiums. So it's actually to distinguish it from sodium, disodium glutamate, and monosodium glutamate. And that's way beyond the scope of what we're doing in here.
Like in our homework and our quizzes and stuff, we won't be writing it.
Correct, yes. Yeah. So to make a short story long, like I'm good at doing, yes, we won't worry about that. Anybody else? All right, next up, we are going to look at binary acids. Binary acids. And this is category number 4. And I think we're going to have enough time to practice some here at the end. So remember now, if it's a binary acid, first of all, what does it mean if it's binary?
One.
It contains 2 elements. And if it's an acid, it contains hydrogen. The hydrogen is written where? At the front of the formula. So again, it's going to have 2 elements, one of which is hydrogen. The hydrogen is written at the front of the formula. So now, a way that we could write this would be something like HCl. And we could label this with a phase label of AQ. Anybody know what AQ stands for? I heard somebody say it. Aqueous. Aqueous. And aqueous also means dissolved in water. And that's simply because we know that when we're teaching people how to do nomenclature, we just want to confuse you as much as possible. Okay? But it turns out that binary acids only have their acid name when we dissolve them in water. The convention we use for these, and I should mention this here, binary acids are only given their acid name when dissolved in water. Otherwise, they are named as binary molecular compounds. So the convention we use for these looks like this. They have a hydro prefix and they have an IC acid suffix. And in the middle here, we have the root name of the other element. So it's a hydro prefix, an IC acid suffix, and then the root name of the other element in the middle. So now, if we have something like HCl, aqueous, we wanted to name this, this would be called hydrochloric acid. Good. Hydrochloric acid. But just so we are aware, if it's not dissolved in water, it actually comes as a gas. We name it as a binary molecular compound. We'd simply call this one hydrogen chloride. Hydrogen chloride. But now, usually chemists will know the context in which we use it. Usually when we see it written with it, if we leave the phase off, it's assumed that we're talking about the acid form of the compound.
Do you want us to add the
If you add the AQ on there, I would not mark it wrong if it's not included. I can't recall what Master in Chemistry does, but it may prompt you to include the phase label. Okay. Let's go ahead and write a formula. Let's take hydroiodic acid. Hydroiodic acid. Now we see the hydro prefix and the IC acid suffix. So because it's an acid, that must mean it includes hydrogen. And the other element in this is going to be iodine. Now to write this formula, we need to know charges actually. So we come back to the periodic table. Hydrogen is going to be H with a charge of 1 plus. Iodine is going to be I with a charge of 1 negative. So we have a single positive here and a single negative. What happens? They cancel out, and we simply wind up with HI. And if we want to make it technically correct, we'd put in AQ. If it comes to an exam, though, and you leave it off, that's okay. And I don't remember what Master in Chemistry does. That was the question that came up here before. But to make it technically correct, you do include AQ. I will not mark it wrong if you leave the AQ off. Okay, let's try this one. You go ahead and do this one. Hydrosulfuric acid. Hydrosulfuric acid. Formula for hydrosulfuric acid is going to be H2S, followed by AQ. If you want to make it technically correct, whether you include it or not doesn't matter, but that's because sulfur has a charge of 2 minus. 2 minus, right? Here, everything in this group has a 2 minus charge. All right. We're just about there. This is our last category of compounds that you're responsible for, and that is category number 5. They are oxyacids. Oxyacids. Now remember, if it's an acid, acids always include which element? Hydrogen. Hydrogen's written where? At the front. If it's an oxyacid, that means it also includes oxygen. Now it turns out with these, simply because I know we want to confuse students just learning, these here always carry their acid name. So we don't name it one thing when it's in water and something else when it's not in water. These here will always carry their acid name. And the rules for oxyacids look like this. First of all, we identify and name the anion present. In the acid. And then what we do is we drop the ATE suffix from the anion name and we replace it with the suffix of IC acid. So what we do is we drop ATE from the anion name, we replace it with the suffix of IC acid. Now remember that most of them, the most common ones that we look at for the oxygen-containing ions, end with ATE. Sometimes, though, if they have one less oxygen, they'd end with the suffix of ITE. And in the case of ITE, what we do is we drop off the ITE suffix from the anion name, and we replace it with the suffix of OUS acid. Now to keep this straight, a couple mnemonic devices might help. One of the mnemonic devices would be, I ate something icky. I ate something icky. Or, ate comes before ite alphabetically, just like IC acid comes before OUS acid. So ate goes with ick, ite goes with the OUS acid suffix. So to do these, let's look at a couple formulas. Let's look at HNO3 and let's look at HNO2. And to do each of these, I like to use what I call the four-square method. Where we kind of just apply these rules in order. So we're going to come up with a name for this one, we'll come up with a name for this one over here. So the first thing we're going to do is we're going to identify and name the anion present. Let's start with the formula of the ion. What is the formula of the ion that's present in this one? NO3 with a charge of 1 negative. And if you're wondering where that comes from, that is right where? Right somewhere in here. There we go. NO3 with a charge of 1 negative. Okay. The name of this ion is called the nitrate ion. So if this is the nitrate ion, that must mean that the name of this acid is nitric acid. Nitric acid. So we replace ATE with the suffix of IC acid.
We don't add hydro for these ones.
No, if we add in the hydro prefix, it's no longer an oxyacid. Hydro prefixes are the characteristic of a binary acid. Okay, so hydro goes with binary acids. The oxyacids do not have a hydro prefix. So we'll do this one. What is the formula of the anion that's present in this acid? NO2 with a single negative charge. And so if it's NO2 with a single negative, the name of this ion is the nitrite ion. The nitrite ion. If this is a nitrite ion, the name of this acid is going to be nitrous acid. Nitrous acid. So in the name of the acid, we drop off the ITE suffix. We replace it with OUS acid. Let's try going the reverse direction. Let's work with chloric acid and chlorous acid. Now, if we're looking at chloric acid has an IC acid suffix, and so kind of working our rules in reverse, chloric acid must have come from which anion? Must have been the chlorate ion. And the chlorate ion has a formula of ClO3 right here. ClO3 with a single negative charge. This is one of them that you had to memorize. Now if we want to write the formula for an acid, that means we're going to combine it with which element? Hydrogen. Hydrogen always has a charge of 1 plus. So if we combine with a single positive charge, we put these two together, we get a formula of HClO3. So then if we want to do chlorous acid has an OUS acid suffix, which means that it was derived from which ion?
ITE.
Chlorite. Well, if you memorize chlorate, this is the one that you were to memorize, that must mean that the chlorate ion has a formula of ClO2 with a single negative charge. Then to write the formula for the acid, we combine it with H plus. So its formula would be HClO2. Any questions on these here? We got 2 more examples, and we're going to do a bunch of practicing. But any questions before these move on from here? Okay, the last 2 we're going to do. We have 2 elements. Have different root names. In anions and acids. And these root names are, so again, these are just 2 elements, because of course we haven't confused you enough already. Those 2 elements are sulfur and phosphorus. Sulfur and phosphorus. And if we look in anions and go to acids, it looks something like this. In anions, sulfur has a root name of sulf, and phosphorus has a root name of phosp. And so we used these already when we talked about something like sulfate, sulfite, sulfide. With phosphorus, we talked about phosphate, phosphite, phosphide. So the root name of these 2 elements was the first syllable. In acids, they actually have 2 syllables. So the root name of sulfur in acids is sulfur, and the root name of phosphorus is phosphor. So we add on 1 more syllable, and it's only these 2 elements. It's only these 2. All the rest of them, the root name stays the same. So we didn't change it. Chlor. Chlor was always chlor, whether it was an acid or an ion. So if we look at an example of this, let's look at something like sulfuric acid. We want to look at something like sulfuric acid. We want to write its formula. And sulfuric acid, by the way, is the acid found in lead acid batteries in your car. The hydrochloric acid we talked about earlier was the acid found in your stomach. So now if we have sulfuric acid has an IC acid suffix, so that must mean it was derived from which anion? It would be the sulf8 ion. And notice now we went from sulfur to sulf and IC acid to ATE. So now the sulfate is one that we were to have memorized. Sulfate has a formula of SO4 with a charge of 2 negative. If you want to write the formula for an acid, we combine it with which element? Hydrogen. Hydrogen has a charge always of 1 plus. So its formula is going to be H2SO4. H2SO4. Okay, I have a worksheet here, a little handout. We're going to be working on this the rest of the hour, where we get to apply our rules. Now these are all mixed up. They're not in any special order. They're not labeled. Oh, by the way, this one is a binary molecular compound. This one is a binary ionic compound. Before you begin applying the rules, you need to know what is it I'm naming. Am I naming an oxy acid? Am I naming a binary acid? What is this? And we're going to go through these at the end of the hour, sort of. You're actually going to be writing your answers up here. Okay, so I have these up here in the nomenclature practice. And like if you're really smart and really fast, you can put a number 12 on yours, and you can try naming this one. All right, and we'll just see how smart you really are. So you can add on a number 12 if you want to do number 12. For this here is sulfur, and sulfur spelled S-U-L-F-U-R, trioxide. And now this is not the sulfite ion. And why isn't this sulfite? Don't worry, it's a very, very common mistake. You're not the only one in here, I guarantee you. But why is it not sulfite? Yes?
Because, sulfite is, oh no, it is a thing, but it's, doesn't have a negative 2 charge.
Right. This here would be the sulfite ion. The key to this is the charge on there. So you're thinking the right thing. You're thinking the right thing, but what you're missing on this one is the charge that's on there. So sulfite, I think we saw a sulfite up here. Sulfite has to be part of a compound like potassium sulfite. Okay? One name up here needs to be fixed yet, though, and what is that? Number 8, yes. And what needs to be fixed about number 8? Take out the Roman numeral, exactly. This is simply going to be zinc nitrate. And why is the Roman numeral not needed on the zinc? Even though it's a transition element, why is it not needed on this one?
It doesn't have a variable charge.
Right, it doesn't have a variable charge. If we come back to our class from last period, zinc is actually one of them here that has a fixed charge at 2+. When it has a fixed charge, there's no Roman numeral included. And in fact, hold on here, folks, hold on. Zinc is one of them you were to memorize. Go back to your list. Where is it? Right where I'm at. Here we go. Zinc is one of them you had to memorize. That's because one of them, the zinc ion here, has a fixed charge. All right. Anybody happen to get the last one? The bonus one? You got it? No? Figure you would have learned by now. This one here is Cocoa Puffs. All right, I know. I don't have a night job. This is my only job. So, practice up on this. This is one of those things, before you leave here, we got about 3 minutes. Nomenclature is one of those things that either you get it or you don't. And when I come to the next exam and give it to you, there's going to be, just like this worksheet, the one thing we did in class today, and this one that I passed out. This is what that page is going to look like on the exam. And it's not quite as many. I think it'll be like about 13 or 14 on there. And if the name is given, you're going to write the formula. The formula is given, you're going to write the name. I generally see one of two scores. I either see perfect or I see 0. And you want to be the one that's almost perfect and not the 0 in here. And the key to all of it begins where we started this chapter, and that is how to classify them. So you break them into groups. You ask yourself, is this an oxyacid? Is it a binary molecular compound? Is this one with a polyatomic ion? Because each one of them has their own set of rules. The second thing I would do is this. I would go and do a web search. And I would pull up something like, let's see, I think I can write this in here real quick. Just show you. I would type in nomenclature worksheet. And when I type in nomenclature worksheet, you're going to see there's a whole bunch of people that puts these worksheets out here. I would just practice a whole bunch of them. And if you practice a whole bunch and you can't find answer keys or whatever else, I will help you with those. The tutors will help you with those to go through that practicing. Then the last thing, I know you want to leave, but the last thing is this. When you're doing your homework, You are responsible for memorizing these right here, but your homework, your textbook, your Mastering Chemistry, doesn't know that I limited you to the ones that you had to memorize. So your Mastering Chemistry may include things we didn't memorize. So your Mastering Chemistry, as long as you have this table here available on page 143, you should be able to get all of them that you may encounter on Mastering Chemistry. But again, it may include things you're not memorizing. You're just going to, for the exam, focus on these whatever 10 that there are. Any questions? Yes?
The periodic table again.
You will get to use the periodic table on your next exam. The periodic table will be just like this on your exam. Anybody else? All right, study up, guys.